Welcome back to section 1.8, part 3. Now we've talked about mass and weight and how they're different. And we're also going to look at another intensive property called density. It's one of the physical properties that we've looked at in class. And this is basically talking about how closely packed are the atoms or molecules or formula units within a particular solid, liquid, or gas. And so the more tightly packed, the more mass there would be per unit volume, the higher the density value will be. Now, different elements on the periodic table have different densities, and they're unique. For example, gold has a density of 19.3 grams per centimeter cubed. So the mass is 19.3 grams for every 1 milliliter or 1 box that is 1 centimeter wide, tall, and long. But for something like aluminum, its density is 2.7 grams per centimeter cubed. And so it weighs almost 1/6, the amount of gold does for 1 centimeter cubed. It is an intensive property, so it does not depend upon the amount of the substance. It is how closely packed the atoms are within a given, certain section that we've pulled out of the element. And so it doesn't matter if we take a very large block of gold or a very small block of gold. The density or the packing of the gold atoms within that sample will always be 19.3 grams per centimeter cubed. Because we said it was a physical property, it is dependent upon the amount, of the size of the object. Now, in terms of the extensive physical properties, mass does depend upon the amount, how big the box is. Volume depends upon the amount of substance, whereas density does not depend upon the amount of the substance. And density is an intensive property. The extensive properties are mass and volume that make up the equation. Now, densities of liquids and gases are affected by temperature. And what happens is typically it is the volume that changes when temperature changes. If something gets warmer, typically the volume will swell. And so what happens is the density of the object then decreases, because if this number gets bigger in the basement of a denominator, the mass staying the same, the density value will get lower. Now, the units of density are typically in grams per milliliter or grams per centimeter cubed. Now, sometimes we'll see it reported in kilograms per liter, but it's always mass per unit volume. Now, you'll notice here that this looks like a conversion factor, and that's because it is. You can go from the volume of an object to the mass of the object, or vice versa. Now, in terms of finding the volume of an object by water displacement, we'll do this in lab, is we'll be given a certain amount of water. Let's say there were 100 gallons of water in this tank. And when the swimmer jumps into the pool, and now we have 150 gallons, that has been measured by the side of the pool, we can see that by difference here, the volume of the person is 50 gallons. Because initially, without her in the swimming pool, it was 100 gallons of liquid in the swimming pool. The dog's going to bark in just a second. And then after she jumped in, it was 150 gallons. And so by difference, her volume is 50 gallons. Now here's some common densities of objects like hydrogen. You'll notice here in grams per liter is pretty small, versus something like wood, 0.75, a lot more dense than a gas is, or bone, 1.80. Cement, look at this guy, 3 grams per milliliter. And so whereas some of the metals like iron, almost 8 grams per milliliter, gold here are 19.3. Now, the density of an object will determine whether or not it sinks or floats. Now, ice floats in water because the density of ice is less than the density of water. And so we'll see here that we have water has a density of 1 gram per milliliter, whereas ice has a density of 0.92. And so if you have a density less than 1 gram per milliliter, you're going to float on the water, H2O. You'll see cork here has a density less than the 1 gram per mil, and so cork floats in water also. But aluminum and lead have densities bigger or greater than 1 gram per mil, and so they sink. And so looking at the density of objects, we can determine whether or not they float or sink, at least in water. Now, we can use density as a conversion factor. And so here it says I bought a hunk of gold for $200 that weighed 7,236 grams and had a volume of 632.1 milliliters. Did I make a good deal? So the question here is, what is the density of the hunk of something that I bought? So I'm going to calculate this because density is just mass divided by volume. So density is the mass of the object over the volume. So I'm going to get that in grams per milliliter. So I have 7,236 grams, and I have 6.321 times 10 to the second milliliters. So if I plug that into my calculator, I'm going to get 11.45 grams per milliliter. This has 4 sig figs. We have 4 sig figs here, so we have 4 sig figs in the answer. Now, this is the density of my object, my hunk of whatever. Do I have gold? Well, because the densities don't match, no, I do not. And so I'm very sorry, but you do not have gold. You have something else, something like lead. Now, it says a certain mineral has a mass of 17.8 grams and a volume of 2.35 centimeters cubed. What is the density? Well, just plug the numbers in. Take the mass and divide it by the volume. We have 3 sig figs here, 3 sig figs there, and so our answer should have 3 significant digits. We could look up this density, and if we had, let's say, an element, we could look at what element has this density. Okay, but because we're talking about a mineral, it means that it's typically a mixture, and so we could not look up what element is actually in this mineral. Now, we can use density as a conversion factor, because it goes from the mass to the volume, and so we can use this as a conversion factor. Grams can be in the basement, or milliliters can be in the basement. So let's use it as a conversion factor. It says a piece of platinum metal has a density of 21.5 grams per centimeter cubed, and it has a volume of 4.49 centimeters cubed. What is its mass? Well, first of all, I want to rewrite this over here, 21.5 grams per centimeter cubed, and that is for the platinum metal. Okay? Now, this number right here it only has 1 unit associated with it, whereas this has 2 units. So I don't want to write this down as something that I want to convert. I want to start with the 4.49 centimeters cubed and get rid of the centimeters cubed. So if I look here at the density, we're going to see that centimeters cubed go into grams. So I'm going to put for every 1 centimeter cubed, it weighs 21.5 grams for the platinum. Centimeters cubed cancel, and I have grams. So if I multiply the numbers on the top and divide by the numbers on the bottom, I get 96.5 grams of platinum, and I have 3 sig figs. Now, the other way to look at this, other than it being a conversion factor, is one student showed me this, where they said density was equal to mass divided by volume. And so what they did was they would take their finger and cover up and says, okay, what is the mass of the object? So they would say, all right, I would like to find the mass. So they would cover that up. And how do you find the mass then? So the only letters left, so we cover this up with our finger, it's density times volume. So here, if you took the volume times the density, we got the mass. So let's say we did this D is M over V. What if we wanted to find the volume of something? you would take the mass of the object divided by the density. So we would take the mass of the object divided by the density, and we would get volume. And so this was a cool thing that a student showed me how to do, because if you take the mass in grams and divide it by density, which is in grams per mil, the grams cancel and the milliliters, which are in the basement of the basement, come up and give us the units of volume. So I thought that was a really cool way to show how to use density as a conversion factor. So thank you to the student long ago that showed me how to do that. Now this one is one of my favorite problems. This is about diamonds, because I'm all about diamonds. And so we're reading through this problem. It says 1 carat is 0.200 grams. So that's a conversion factor. So I'm going to write it as a conversion factor. And I may have to turn it upside down, but I do know that this is a conversion factor. And this has been weighed by someone, okay, as a definition. And so here we actually have 3 significant digits. This is something that someone weighed and defined. Now, density also is typically someone has to measure this, and so density does not have an infinite number of significant digits. And so this has 3 sig figs also. It says, what is the volume of a 5 carat diamond? So you'll notice the question mark is here with the 5 carats, so that's what we want to start with. Let's get rid of the carats. Now, a lot of the times when I start with these problems, I may not know where I'm going, but I got to get rid of the unit I don't want. So if I look up here on my conversion factors, let's get rid of the carats at least. So I may not know what direction I'm going in, but at least I can get rid of this very first unit that I don't want. So carats go away, and now I have grams. I want volume. So if I look up at my density, the milliliters here, okay, have the grams in it, and milliliters are unit of volume. So I'm going to use this conversion factor, but I'm going to make sure that the grams go in the basement so that they cancel. And that's 1 milliliter. So grams cancel, and I have milliliters. So if I multiply the numbers on the top and divide by the numbers on the bottom, I get 0.284, and that is milliliters. There are 3 sig figs here, 3 sig figs there, and 3 sig figs there. So my answer has 3. Now, I always tell this story that when I was getting engaged to get married, my boyfriend had asked me, he wanted to know what kind of ring I wanted. And I actually did not want a diamond ring. I wanted an emerald ring. And he said, but I want to buy you something traditional. And so I said, fine. I really don't want a diamond, but I said, okay. We were at dinner and I said, I want a diamond that has a volume of 2.8 milliliters. And he's like, whatever you want, honey. And I said, seriously? Because he was, at that time, a political science major. So he had no idea about conversions. So I whipped out a pen and I wrote on a napkin and I said, this is what you've just agreed to. So I want to tell him how many carats 2.80 milliliters is. So starting out, so everybody, you can use this on your next date. Let's get rid of units of milliliters. Here are our 2 conversion factors. So milliliters is in this conversion factor, so we're going to use it. For every 1 milliliter, a diamond weighs 3.51 grams. So milliliters cancel here. And then, of course, we can go from grams to carats. So for every 0.200 grams, that is what 1 carat weighs. So the grams cancel. And so I showed him that he was agreeing to buy me a 49.1 carat diamond. Needless to say, I got my emerald ring. So, long story short, if you say you can have anything you want, everybody out there ask for the 2.8 milliliter volume diamond. And then using dimensional analysis, you can show what they've agreed to. So this just goes through our math, so we'll just cruise through this. Now, this particular problem is dealing with the Star of Asia sapphire. It weighs 330 carats, okay? And it's saying here, let's make sure that has 3 significant digits. So let's put a decimal behind there or put a line over the 0 for 3 sig figs. What is this weight in grams? Now, it says right here, the milligrams, let's say that's exact. And so they're saying we're going to have an infinite number of significant digits for the 1 carat is equal to 200 milligrams. So I'm going to put up here my 1 carat is 200 milligrams. And here, the number I'm going to start out with is 330 carats because it is the only number in here that has only 1 unit on it. So 330 carats. Let's get rid of the unit of carat. So 1 carat is 200 milligrams. But it wants the weight in grams. So we're going to have to get rid of milligrams here and go into grams. So you need to know what is your conversion factor. So hopefully you know there are 1,000 milligrams in 1 gram. So if we multiply the numbers on the top and divide by the numbers on the bottom, we're going to get 66,000, okay, times 10 to the minus 3. We're just looking at our numbers here. So what I finally get in my calculator as it comes out is 66.0 grams. There are 3 sig figs here, infinite number, 3 sig figs in my answer. And this is how many grams the sapphire will weigh. Now, this is really cool. An old-fashioned unit is called a cubit for unit of measurement. And so it says the dimensions of a ship that were reported as 3.0 times 10 to the 2 cubits by 50 times 10 to the 1 cubits, express the size in units of feet and in meters. So first of all, I want to look at how many feet by how many feet, and then how many meters by how many meters. So this is going to be a 2-part problem. This gives us 1 conversion factor, a foot to a cubit. So here, if we have the 3.0, and actually let's put that on there, the 3.0 times 10 to the second cubits, 1 cubit is 1.5 feet. Okay, and so if I multiply that, I get 4.5 or 450 feet is the first unit converted from cubits into feet by 7.5 or 75 feet, or 7.5 times 10 to the first feet, or 75 feet. So here is the area. 450 feet by 750 feet, 75 feet. If we want to change this into meters, okay, and this says this has an exact definition. 3 feet in 1 yard is an exact definition. This one is measured. Oh, did they say exact in this problem? They said exact in this one. Nope, they said measured. If we do this, and we want to convert, here we have our feet from our last part. We can take a foot into a yard and then a yard into a meter, okay? And so we can get our dimensions over here, 1.4 times 10 to the second meters by 23 meters on the other side. Now we've done a lot of conversions, and I'm going to actually do some more in the next part, but I want to kind of get us to a point where we're showing all our work. Please put units on every single unit. On every single conversion. For example, this conversion, I would say is going to be worth 5 points. So 2 points for this conversion, 2 points for this conversion, and 1 point for the answer. And so let's say we were writing this out. We had our 4.5 times 10 to the second feet. And in our first conversion, we switched out the numbers. We actually put the 3 feet upstairs and the 1 yard downstairs. But then we did the rest of the problem correctly. And so we had our meters upstairs and we had our yard downstairs. This conversion would result in a -2 because I would say this is upside down. I would do an arrow here. But the rest of the problem would be correct. Now my answer would not be correct. My answer would be in meters, but it would be some number that is not 140. But In a 5-point problem, I would have only lost 2 points because I accidentally flipped this conversion factor. And that's why you want to make sure that you show all your work. If you do this and just give me an answer with no conversion shown on the piece of paper and your answer is incorrect, you're going to get -4 because you have an answer with the correct units, but the number's not right and I don't know how you got that number. And so just realize that some of you have graphing calculators that do some of these conversions automatically. But if you just give me an answer and you don't show me the work on your exams, you will not get partial credit if the answer is incorrect. So you need to show all your work on the exams. Now, the conversions that you need to know are English to metric. You have a conversion sheet. So those you are given. So the metric to metric, you are responsible for all the prefixes on the next slide, which was table 1.1 from the textbook. Some things you should know though, okay? So you should know these. You should know how many inches are in a foot or how many feet are in a yard. That's something you're going to need to know. So if you have not grown up in the United States and you do not know the English system, we're assuming, because you're taking class in the United States, that you know that there are 3 feet in a yard. That is just something you will need to know. For example, you will need to know how many ounces are in a pound. There are 16 ounces in 1 pound, okay? And there are 4 quarts in a gallon, okay? Now, you should know things about time, okay? So how many seconds are in a minute, how many minutes are in an hour, you know, that type of thing. You know, how many years are in a decade. Hello, dec means 10. And then, of course, these prefixes. These prefixes, you will need to know all of these from table 1.1. We're using the Greek letter mu for micro, so that's a funky looking U with a big tail in front of it. We are not using this MC. And you do need to know the multiplier. So 10 to the -6, 10 to the -9. So know all of these for your note card. All right, so I'm going to come back and do some more problems in part 4 of conversions, but thank you for listening to section 1.8.3.